Cloud Practitioner Certification, Technology section, Compute. First topic, Elastic Compute Cloud, also known as EC2. Amazon Elastic Compute Cloud, also known as EC2, is the fundamental compute service in AWS. With EC2, you get the following benefits. You can launch an EC2 instance within minutes. You can stop the instance when you don't need it. You pay only for the runtime of the instance. You pay only for the server capacity that you need. They are resizable. This is called vertical scaling. Next topic, instance types. EC2 instances are optimized for different tasks. When selecting an instance type, check which instance type satisfies the requirement of the workload. The instance types are general purpose, compute optimized, memory optimized, accelerated computing, storage optimized. General purpose instances provide a balance of compute, memory, and networking resources. Select this instance type if your application requires roughly an equivalent amount of compute, memory, and networking resources. For example, for application servers and web servers. Compute optimized instances are ideal for compute-bound applications that benefit from high-performance processors. You can use compute optimized instances for tasks such as web servers or gaming servers. Memory optimized instances are good for workloads that process large datasets in memory, for example, high-performance database. Accelerated computing instances use hardware accelerators to expedite data processing. They are good for applications such as graphic applications, game streaming, and application streaming. Lastly, storage optimized instances are designed for workloads that require high amount of read and write access to large datasets on local storage. Examples of workloads suitable for storage optimized instances include distributed file systems and data warehousing applications. Next topic, EC2 pricing models. There are a few pricing models to rent EC2 instances. First model, on-demand. With on-demand model, you pay for the instance runtime. If you stop the instance, you don't have to pay until you start it. They are good for developing applications, testing applications, or running applications with unpredictable usage patterns. Second model, reserved instances. Reserved instances are a discount applied to on-demand pricing when you commit to use a specific instance for a longer time. I would like to emphasize that the commitment here is to use a specific instance. This means that you have to know the EC2 instance type, size, number of instances, operating system, and region. The term can be 1 year or 3 years. You realize greater cost savings with the 3-year option. Third model, savings plans. EC2 instance savings plans reduce your EC2 instance cost when you make an hourly spend commitment to an instance family and region for a long time. Now remember, in reserved model, the commitment is to use a specific instance. But with savings plans, the commitment is to spend a fixed hourly dollar amount for an instance family. It's not specific to an instance. So unlike reserved instances, you don't need to specify upfront what EC2 instance type, size, OS, and tenancy to be used to get a discount. Similar to the reserved model, the term can be 1 year or 3 years. This term commitment results in savings of up to 72% compared to on-demand rates. Fourth model, spot instances. Spot instances use unused Amazon EC2 computing capacity and offer you cost savings at up to 90% off of on-demand prices. Spot instances are ideal for workloads with flexible start and end times, or that can withstand interruptions. Fourth model, dedicated hosts. Dedicated hosts are physical servers that are fully dedicated to your use. They're typically used in scenarios when a physical server is needed for hardware-based licensing. Next topic, scaling. There are two types of scaling. They are vertical scaling and horizontal scaling. Vertical scaling is changing the instance size. And horizontal scaling is adding or removing instances to match the demand. Auto scaling is automatic horizontal scaling. Auto scaling can increase the availability of your application and optimize costs. Next topic, auto scaling group. Auto scaling group is a collection of EC2 instances created for the purpose of maintaining a desired number of instances or scaling out or in to match the demand. An auto-scaling group creates a new instance if an instance goes down or it has to scale out because the demand goes up. How does it know what instance to create? That's when we need a launch template or launch configuration. An auto-scaling group is associated with a launch template or launch configuration. A launch template or launch configuration is the blueprint for creating a new instance by the auto-scaling group. Next topic, auto-scaling group settings. When creating an auto-scaling group, following settings can be used. First setting, minimum capacity. It's the lowest number of instances at all time. Second setting, maximum capacity. It's the maximum number of instances the auto-scaling group can have at all time. The third setting, desired capacity. The desired capacity is the number of instances the auto-scaling group attempt to maintain. After creating the auto-scaling group, you can change the desired capacity manually or automatically based on a CloudWatch metric. But the desired capacity can never go below the minimum capacity, and it can never go above the maximum capacity. Next topic, maintaining a fixed number of instances. Previously, I mentioned that auto-scaling group has two purposes. Purpose 1, maintaining a fixed number of instances at the desired capacity. Purpose 2, scaling the desired capacity to match the demand. How does an auto-scaling group maintain the desired capacity? An auto-scaling group uses a health check to monitor the healthy instances. If it detects an unhealthy instance, it will terminate it and create a new instance. Next topic, manual scaling. By default, an auto-scaling group does not automatically scale, but you can simply change the desired capacity to manually scale. Again, this is the default behavior of an auto-scaling group. It's useful when auto-scaling is not needed. Next topic, auto-scaling. You can attach a dynamic scaling policy to an auto-scaling group to scale it automatically. A dynamic scaling policy is usually based on an AWS CloudWatch metric and a target value, which represents the ideal average utilization or throughput level for your application. To maintain the target, the auto-scaling group will scale in or out. By default, an auto-scaling group is not associated with any dynamic scaling policy. Next topic, load balancer. A load balancer can distribute traffic across multiple instances. Next topic, load balancer with auto-scaling group. We have talked about auto-scaling, which can scale in or out to match demand. But an ability it doesn't have is the ability to distribute traffic across multiple instances. A load balancer can distribute traffic across multiple instances, but it doesn't have the ability to scale a group of instances based on the demand. This is when we need to join a load balancer and an auto-scaling group. Without joining, both are incomplete. To distribute traffic across an auto-scaling group, you can associate a load balancer with auto-scaling group. Then the load balancer becomes a single point of contact to the auto-scaling group. The instances which are added by the auto-scaling group are automatically registered with the load balancer. The instances removed by the auto-scaling group are automatically deregistered from the load balancer. Next topic, load balancer as a router. We know that a load balancer can distribute traffic across multiple instances. In load balancer terminology, these instances are called targets. Targets can be categorized into multiple groups, and they are called target groups. A side note, when we associate an auto-scaling group with a load balancer, we are associating with the target group. Within a load balancer, you can define rules to route traffic to different target groups based on the request attributes. Next topic, Amazon Simple Notification Service, SNS. SNS is a publish-subscribe service. Using SNS topics, a publisher publishes messages to subscribers. This service is mainly used to create loosely coupled microservices. Next topic, Amazon Simple Queue Service, SQS. Using Amazon SQS, you can send, store, and receive messages between software components without losing messages or requiring other services to be available. In SQS, an application sends messages into a queue. A user or service receives a message from the queue, processes it, and then deletes it from the queue. Similar to SNS, this service is also used to create loosely coupled microservices. Next topic, serverless computing. With EC2, you have to provision the instances and manage them. With serverless computing, the application still runs on servers, but the idea is that you don't have to provision or manage the servers. Next topic, AWS Lambda. AWS Lambda is an event-driven serverless compute service. With Lambda, you pay only for the application code execution time. You don't have to pay for the idle time. Lambda is used for event-driven applications. For example, when you upload a file, if you want to convert to a different format, you can invoke a Lambda function on file upload. The last topic of this video is containers. With EC2, the application environment has to be installed on the instance and the code has to be pulled into the instance. Unlike EC2, containers provide you with a standard way to package your application code, configurations, dependencies, and environment into a single object. Containers are a powerful way for developers to package and deploy their applications. Amazon Elastic Container Service (ECS) and Amazon Elastic Kubernetes Service (EKS) are container management services. Additionally, AWS Fargate is a serverless compute service for containers.